Now let's move on to question 3. Instead of using letters P, Q, and R, etc., we actually have actual propositions. So this is actually a traffic light example. So M for a traffic light, this is our model. So initial state starts off as red. From red it goes to yellow. From yellow it goes to green. From green it goes back to yellow, and yellow goes back to red. So the reason this is red / yellow is just differentiating between the two yellow states. So this is the yellow after red as opposed to the yellow after green. So we have 4 states. We have 3 atomic propositions, red, yellow, and green. And we have 4 different transitions. So let's answer our questions. So the first question is G of F green, always eventually green. So this is actually a liveness property. So this is saying a traffic light is green infinitely often. In other words, a traffic light will always eventually go to green. Which in our case, so something good will happen. In our case, if you're on red, you won't be stuck on red forever. You won't be stuck in yellow forever. You will eventually get to green. So this is always true. So let's see, we start off at red. We can only transition to yellow from red, and from yellow we transition to green. So yes, it is true that always eventually green. Now, if you go on to timed automata, which is another area model checking, there will be time invariance between how long it takes to go from red to yellow, how long it takes to go from yellow to green. But for now you can just assume it happens, let's say every 5 seconds, it doesn't matter, just that it does occur. So that's true, so that's an easy question. Our next question is, in brackets a bit better. It is always the case that red implies not of next green. So what does this mean? So not of next green, this means the next state is not green. So saying whenever red is true, is implying that the next state is always not green. So you can't go straight from red light to a green light, from a red state to a green state. So again, we can do our table. I'll pause while I build my table. Okay, so let's do the table just in case you can't see it. So we can do where's red true. Let's say red is state 0, this is state 1, state 2, state 3. So we're going clockwise with the states. So red is true in state 0, yellow is true, states 1 and 3. Again, we always start from 0. And green is in state 2, so down here. So next is green. What states are these? This would be when in state 1 and where it is yellow. So we're in state 0, red, we go to state 1, yellow, and then we go to green. So we're in yellow, state 1, the next state, state 2, is green. So not X green. So that means it's the opposite of this. So that would make this true, and this true, and this false. So now red, this is red. You can't read it. Red implies not X green. So when red is true, the next, not next of green. So red is true here, yes. The next state is not next green. So, yes. So, When you're in state 0, red is true and not next of green. So is it true that in the next state it is not green? Well, yes, because the next state over is going to be yellow. When we go into state 1, red is false, so this is always going to be true. So again, just in case you didn't get that, red implies not of x green. So we're in state 0, we check against not of x green in state 0. So we're not checking the next, we're checking not the next. So in state 0, not of x green is true. So true implies true. This is why we get true here. Just in case that's not clear. And for states 2, 3, or states 1, 2, and 3 rather, red is always false. Anything times false is always going to get a true value. So we're checking this value in state 0 when red is true against the one above it, and not x of green. So that is how it differs from the previous question in question 2, if you're wondering why we're not going into the next state. Now we're asked, is this always true? Is it always red implies not of x green? Well, we can see it's always true. So let me move. So we can say that this is true. Once red, the light cannot become immediately green. That is what this is saying. Once red, the next transition will not be green, because it always goes to yellow, as you can see here intuitively. You're in red, it always goes to yellow. So now, let's go on to the next question. Now, part 3 is a rather large formula. In fact, it's even hard to fit in to the screen. We might scroll that over and bring that over. There we go. So, what is this saying? So we have G of red implies X red until yellow and X yellow until green. So let's break this down into English first. So once red, the light always becomes green eventually after being yellow for some time. That is what this means. Okay, so let's go through this. I've built the table here quickly once more. Zoom in a tiny bit. So you see we have state 0, state 1, state 2, and state 3. Again, we have red, we have a yellow, we have a green, same as the table above. So let's start with yellow until green. So what states does this hold? In red, well, yellow's not true yet. Here, yellow is true. Is it true until green? Yes. And here, yellow is true. Is it true until green? No, because this transitions to state 0 where it's red. So it's no longer yellow, but it is red and not green. So it only holds in states 1 and states 2. So next, we have yellow, X, Y until green. So in what states next does Y until green hold? Well, state 0, yes. In the next S1 it holds. S1, yes. S2 it holds. State 2, no. In the next state, y until g does not hold. So for this, it's just state 0 and state 1. So it's the next state. So now we have S0, S1. So now yellow and X, Y until G. So yellow and next Y until G. So does it hold in state 0? No, because yellow is false. Does it hold in state 1? Yes, yellow is true. And X, Y until G is true. So now we have red until Y and X, Y until G. So red until X until this formula up here. So red is true in state 0, yes. Is it true until this value, till state 1? Yes. So red is true, then it's not true, and then this is true. This whole statement is true in state 1. So this holds here and here. Now, so we can move on to the next section, is X of or until Y and X, Y until G. So we're now at this part of the theory. So in the next state, does this hold? So state 0, yes. Does it hold in S1? It does. In S1, does it hold in S2? It does not. In S2, does it hold in S3? It does not. In S3, does it hold in S0? Yes, it does. So you can see in the next state over, so in state 0, it holds in state 1, true. State 1, it does not hold in state 2, 2 does not hold in 3, 3 it holds again in state 0. So you can see how we're going around in a circle. And now, red implies, I'm not going to write out that formula, I'm just going to use dots to represent this formula up here. So red is true. So in state 0, red is true. It implies this. Is that true? Yes, it is. Here, red is false. So it's also going to be true. It's always going to be true. Again, once more. And now it's G of this. So it's always going to be red implies dot, 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 dot. So is this always true? Is this statement always true? Well, we can see in state 0, state 1, state 2, and state 3, yes, it is true in all the states. So again, we get true. Let me write that a bit better. We get true. And that is how you would go through this thing. Now, this is the reason. Let me get this just one sec. This is the reason we have model checkers. So we can prove all these theories using tables as such. However, you can see that these will grow very, very large if we introduce additional propositions. So again, if we had 4 or 5 additional colors, these tables could grow very, very, very large. The more states and the more complicated they come. So this is why we have model checkers which do this for you. So they'll take your model, they'll take this formula, and it will determine whether your model satisfies this formula, giving you true or false. If it's true, it'll just tell you it's satisfied. If it's false, it will give you a path through your model in a similar way to this, and it'll tell you where this fails. And that is it for question 3. And so last question of this lab. We will move on to CTL in the next lab.